Alright, this is Mr. Gillum, and today we're going to be looking at an example problem from your Paxton Problem Solving book on page 143. The problem says that rectangle LMNK is reflected across the x-axis to get rectangle PQRS. How do we know the coordinates of point L change when it is reflected across the x-axis? And so then it goes on to explain the answer here, and it kind of shows the diagram here. So what was given in this problem before the example would have been worked out would be the coordinate plane. Emphasize the x-axis, the y-axis. It's continuous is what that word is. Those numbers go on forever, so we put little arrows at the end. And it would have given us this rectangle here. So we would have started with this information. And it says that rectangle LMNK is reflected across the x-axis. So it's important to understand that we reflect across the x-axis like folding along the x-axis. So folding the top down on top of the bottom. So believe it or not, this is all related to absolute value. The distance of m, 1, 2, 3, from the x-axis will be mirrored, 1, 2, 3, away from the x-axis on the other side. This is 3 away, this is 3 away. This is 6 away, this is 6 away. 6, 6. So it's all mirrored across the x-axis, the same distance of each point, just on the other side. And to represent the position, we just use negative numbers. Something to keep in mind is that when we reflect across the x-axis, x values stay the same. When we reflect across the y-axis, y values stay the same. Okay, and so if I had just these points here, L, K, M, and N, and they made a quadrilateral, in this case a rectangle, and we reflected them across the x-axis, what would happen is that the y values would change, the x values would stay the same. So if LK was at 2, 6 before, its counterpart would be 2, negative 6. Okay, just the y value changed, the x would stay the same if we're reflecting across the x-axis. If the point M was at 2, 3, then we would have the same point with an opposite y value on the other side, 2, negative 3, that would be Q. And so this process happens for each of these points, 6, 3. The x value again is the same because we're moving in the same direction, right and left, so the x value doesn't change, but the y value will be the opposite, 6, negative 3. You can see that the y values have changed on each of these points, 6 to negative 6. And then our final one will be 6, 6. And again, we're going to change just the y value, and this point should be 6, negative 6. You can see if I folded over the x-axis that rectangle LMNK would land on top of LPSR. So it says the coordinates of point L are 2, 6. The reflection would be 2, negative 6. The x-coordinate of the reflection of point L is the same as point L, but the y-coordinate is the opposite sign. So that's pretty much summed up with these two statements. If you're reflecting over the x-axis, x stays the same. The y-axis, y would stay the same. And that's pretty much it for today.